rather than me saying, yes, I just agree with this wholeheartedly. All right? That's the point. For example, I still actually see that Scrum can have quite a useful impact in places when done correctly. It can also be a wonderful tool for micromanagement and crushing the will out of people done the other way as well. Right? It depends on your intent. It's not the tool, it's how you use it. This one I'm starting to agree with more every day, by the way. I don't have an Agile certification. If you want them, great. They're worthless. That's fine. This one I absolutely, of course, 100% agree with. Okay. Let's get a reminder of some of the Agile principles. Remember, there's 4 values and 12 principles in the original Agile Manifesto for Agile Software Development. That's what the thing's called, by the way. It's not called the Agile Manifesto. It's actually called the Manifesto for Agile Software Development. Those last 2 words are the ones that I'm interested in, right? That we keep forgetting. So one of them was working software is a primary measure of progress. That one gets forgotten a lot. All the principles I'm putting here are the ones that we sort of forget sometimes. Continuous attention to technical excellence and good design enhances agility. And simplicity, the art of maximising the amount of work not done, is essential. So those are 3 that I, again, see not quite getting the same focus as some of the others. People talk about working every day with the business, which itself is, you know, not something that people quite understand. Yes, we work with the product owner who, through 3 lines of communication, finally talks to somebody somewhere in the business. Well, that's not working with the business daily, but you get the idea. All right. So one of the most important things in software development is really beautifully illustrated in a diagram I replicated from a note by Kent Beck. And that's the link there. I'll post the slides on Conf Engine. You can go to these places yourself later. But he talks about how you reason about components of your solution to someone's problem, which is what your software is. You still have to solve someone's problem. And whether they are actually separated. So if you can reason about them separately, and you have separated them, it looks like this. You've got a piece here and a piece here, and there's a sort of connection between them. And I'll talk about why this is like dots in a moment. If you have everything over here, you can't reason about it separately, and you haven't separated it out, it tends to be this larger clump of stuff, which is fine. If you can reason about it separately, but you haven't separated it, it's sort of like clumped together but probably shouldn't be, is the point, right? This is a lump of stuff. You could start separating it out and making it more like this. Then there's the worst place to be in this diagram. If it can't be reasoned about separately, but I separated it anyway because it's cool. Okay, and a lot of microservices projects end up like this, actually, right? In your code, anyone who knows C#, a partial class is this. Some of the classes over in that file and some of the classes over in that file. Why? Well, we don't like classes longer than 100 lines. So you put them in separate files. Yeah, where do I put my code? Pick a file. That's that, right? Microservices that connect to the same database are this, because they probably can't be reasoned about separately. Or ones that call each other in real time, those kinds of things, okay? This is the worst place to be in software. It's awful. Because it means that things are tight, and this is where the lines matter. This is tightly coupled, and that's your problem. They're tightly coupled, but they've actually been separated out. Whereas this is loosely coupled, and the parts that stick together have tight cohesion. So we're going to go over those in a moment. This is tight cohesion with loose coupling. This is tight cohesion, but tightly coupled, right? Because I can't really do much about it. At least, not yet. Maybe we learn something, we can separate them out. But they belong together, so this is not as bad. So some monoliths can be okay. If genuinely everything actually belongs together and changes together, and I can only reason about it all in one thing, we'll put it all together. That's fine. Don't do this. That's awful. And which service do I put my code in? Oh, I don't know. We just sort of split them up. We flick the card. Maybe it's reused for your poker cards. Which service goes in there? All right, so I mentioned loose coupling. So loose coupling and tight cohesion are probably two of the most important things you can work on in software. Because if you know about those two things, you write your software with these in mind, it's easier to change and maintain. If it's easier to change and maintain, it's cheaper to change and maintain. And actually, all of this comes down to how much money you want to spend on software at the end of the day. Right? I'm going to pause for a minute. Everything I'm talking about here tends to start applying when you care about how much money the software costs. Now, that sounds like, well, I always do. Well, sort of. There's that first part when you even figure out, do you have an idea people care about or not? That's where the lean startup kind of mentality is. Simon Wardley calls it the Genesis phase. Kent Beck would call it the Explore phase, where actually some of the stuff I'm talking about here isn't quite as important because you'll probably throw away, yeah, right, you will, sure. You should throw away what you've come up with, trying to figure out if you even have an idea people want. You throw that away and then you start on the next bit. You extract out what people actually do need and want and will pay for, and you build something that will last for the longer term. So that's Kent Beck's extract phase, and Simon Wardley would call it the in-house development phase. It's after Genesis, right? And you can go look all those things up. Again, this is more about code, so I'm not going to go into all the airy-fairy, hand-wavy stuff. I'm going to go into actual stuff that helps with code. But these all relate to each other. And again, it's all about solving a customer's problem. If you're writing code for its own benefit, well, why? So another thing that helps with this is composition over inheritance. So if you're doing a language or using a language where object-oriented programming is generally how you're getting stuff done, a lot of people will use inheritance because, again, it's cool. It's probably not what you need. The reality is inheritance is its own tight coupling. And you're actually better off with composition most of the time. And a lot of that comes down to the is-a versus a has-a relationship. People mistake them. And is-a is literally, this thing is that. It's just a different, it's like a more specific kind of that. That's an is-a relationship. That's where you should use inheritance. Composition is it has a thing. It has a widget that does stuff. And other things might have that same widget. Don't share that out with an inheritance tree. Share that via composition. Inject it into the constructor and actually use it. And then you can actually write your tests to say, well, I brought this thing in via an interface. I use it, and I just check the discussion over that interface. That's it. That's how you test that. All right, so the other thing you can do is functional code. And you throw away some of the object-oriented stuff. And you can use these together, then it's not an either-or, believe it or not. Functional code has a lot of benefits. When I talk about functional, I mean the kind of stuff you would have to do if you were picking up Haskell as a language. If you think that functional code is just a slightly different syntax that looks cooler around normal object-oriented code or something, or it's just like a cooler way to write code, go and learn Haskell. Because you will understand, oh, it's actually a different way of thinking about code. Because I was the same. I thought, oh yeah, I get it, functional, it looks a little bit cryptic, and it's because people doing functional code love single letter variables because it makes them look smart. Okay, don't do that, right? Long variable names are great. But then I pick up Haskell and I'm like, oh. Because, you know, how do you, things like adding up numbers, right? In a normal piece of code you would say the numbers from 1 to 10. I actually have an example of this we may get to. The numbers from 1 to 10, you normally do something like a loop for I equals 1 to 10, and in the middle you'd say A, which is, or your sum, which is your current like total, equals sum plus I, or something like that, right? Yeah. Can't do that in Haskell because every single variable is completely immutable. So once you've assigned the value to sum, you can't change it anymore. But how do I add them? Well, you don't. You don't do it that way. So what you do is you actually come up with the range of numbers, and then you use what I'm going to get to in a moment, which is a reduction operation on them, right? The benefit of that is I'm not changing the values of stuff, and I don't ever have to worry about the state of things because there is no state, right? So what functional code comes down to is trying to eliminate the unnecessary management of state in your code. That's a massive win because then stuff becomes utterly predictable. And in fact, in Haskell, you can represent your code as a series of functions. And if that function, for any given value, always returns the same value, which it has to, because that's what a function is in Haskell, you can actually replace that function with the actual value and the code just works the same. That's the point of Haskell. If you try and pick it up, you'll understand this is much deeper than you'll get in 5 seconds of me explaining it here. And I could do a many-day course on my complete noob knowledge of Haskell and still actually keep your heads would explode. So we won't get to it in this session. Declarative programming. So this is another thing that sort of helps. It relates to functional programming in general, but it helps make it much more obvious what's going on. And I have specific examples of this in a moment. Things like map, filter, and reduce, which I've got up as examples, are declarative programming instead of the loops. And that loop example I just talked about, adding the numbers from 1 to 10, that loop is nothing to do with solving your problem. That I that people use is nothing to do with solving your problem. I just want the numbers from 1 to 10 to be added up. That's my problem, right? Declarative programming is, hey, for the numbers from 1 to 10, ideally your language has a range thing that says the numbers from 1 to 10. Literally, you can create that. If I want to add those, I just say either dot sum, that would be ideal, and some places have that, or dot map filter reduce, dot reduce with the add operation. I'm just reducing those numbers down to the addition of those numbers. And I'll actually show you the working code in a moment. So that's map, filter, and reduce. They're simple examples of declarative code. Let's jump out real quick to an editor and let's see some examples. Now, I've sort of guessed at a font size. If anybody with serious sight problems, and obviously no shame, just let me know if that's the wrong size for you. But let's see, I've got the numbers from 1 to 10 somewhere in here, summation. So, summation test, no, obviously I didn't write that test properly. That's a different problem. So unfortunately in JavaScript it's a little bit harder to get a range. So this is actually a spread of an array containing the numbers, that'll be 1 to 10 basically, if I take the keys of that, right? So that is a minor mucking around I had to do to get a range in JavaScript. So I'd make that a function probably. I'd say, call it range, and that would be down the bottom, which we could refactor if we get some time. But there's my reduce operation. So I'm saying, get the numbers from 1 to 10, and then add them up. That's my problem. That's what I want to do, right? So that's much more declarative. In other words, I'm not worried about what does declarative mean. I'm not worried about the mechanics that's going on under the hood. Under the hood, this is probably looping over these numbers and adding. I don't care. It's not my problem. That's the code's problem. I'm thinking about what problem do I want to solve, right? That's what declarative stuff is about. In infrastructure world, things like CloudFormation and these other sort of templated languages, which are just JSON files, they're declarative programming as well. SQL is largely declarative programming because I guarantee you that table things and select star where this, that, and the other, that's got bugger all to do with the file system underneath the thing if you ever look at the file system of these beasts, right? So it's much more declarative. You're not worried about, I need to look at the rows in this file, at this index on this thing, and then there's another thing. If you actually looked at that code, you'd probably take up gardening for a living instead. But you're declaring, I just want, in my mind, what is this table, and I want to select everything from these rows and add it to this and sum that. Right? That's declarative programming. And it means it's much easier to understand the code. Remember, code is mainly to be read a lot rather than for the computer, right? The compiler takes care of what's for the computer. I need to be able to read and change the code. And more importantly, the tests need to be comprehensible as well, right? Okay. Let's go back. Oh yeah, that worked great. I apparently had more than one window. I don't know why I had more than one window. Really? Okay. Right. How am I going for time? Yeah, okay, we're halfway through. XP. So remember our heavily inflammatory first slide had XP over Scrum. Well, some people may not even know what was in XP and where it came from, which again sort of points to which one won in the certification wars, right? So, extreme programming was invented by Kent Beck. That's a real brief summary, and it's completely wrong, but it's close enough for our purposes. So there are some elements of XP that really apply here. And I'm not saying you should just do XP and stick to it religiously, like, you know, some people would say you should just do Scrum or SAFe or any other framework. Do it. No, because that doesn't help. One of the primary rules of XP is fix XP, actually. I will contrast that, and I know some people in the room have challenged Sutherland on this themselves. There is a rule in Scrum that says the Scrum Master enforces Scrum, I think is the wording now. Correct me if I'm wrong. That's still in the Scrum Guide to this day. I'm just going to leave that comment there. What is TDD? It is this. It is write one failing test, make that test pass, and then refactor the code. And then go back to the start and write one more failing test, make that test pass, and then refactor the code. That is in TDD in its entirety. Anything more or less than that is not TDD. And it doesn't mean it's bad, it's just not TDD. So if you want to do something else, that's great. But don't call it TDD. There's no points for calling it TDD. No one's going to care. Okay? It's the same with Scrum. If you want to do Scrum, great. It's in the Scrum Guide. Anything you do inside or outside of that Scrum Guide isn't Scrum, and that's fine. But don't call it Scrum. It's weird how people... maybe it's CV-driven development or something like that. I don't know what it is. But it doesn't matter what you call it. Do what works for you. Okay? If TDD doesn't work for you, great. It's worth experimenting to try and figure out why it doesn't work for you, because I think it's frigging amazing. But it might not. That's okay. But this is what it is. And we will demonstrate TDD in just a second. I just got to remind myself what's in that. Yeah, okay. Come to the end of these slides, and then we'll go and do a quick TDD exercise. Pair programming. Pairing is really important as well. Not just to get seniors mentoring juniors. That is one great way it works. But in fact, two juniors just pairing on something that both of them are completely clueless about. It's amazing what they can come up with, because no one needs the whole solution anymore. One might have great Googling skills, and one might have picked up good debugging skills, but they might still be utterly clueless. That's not the blind leading the blind. It's two smart people you hired for a reason, working with each other and filling in the whole solution. Likewise, two seniors can actually pair really nicely and actually still inform each other, because no one knows everything, right? So, and also, yes, you can have things like the person you have in the QA role. I don't know why I'm doing that, but for some reason, I don't know why QA is a separate role, like an actual position title. It's a hat you wear, but anyway. But if you have QA people with, you know, QA in their job title, they can pair with developers. That's much better than them going at the end of the process and saying, oh, you missed this, this, and this, and then going all the way back here, and then the developers get really annoyed, and then they come back, no, you missed this. That's wasteful, right? Pairing with the developer doing the work, wouldn't that be much quicker and easier? Yeah, right? Likewise, a BA could, again, should be a hat, but anyway, a BA could pair with a programmer as well. The BA and the QA could pair together. Pairing can apply all over the place. People from the business, again, why that's separate, they can pair with people. It's amazing what you can achieve. And that's where the declarative stuff and test suites that act as specs, those kinds of things, help out a lot as well, because they're readable by people who don't write code for a living every day, and they may be just enough familiar with it to understand what's going on, and you can achieve heaps. And that's why I like spec-style testing rather than just the XUnit style stuff, and I'll show you that in a moment as well. This is why pair programming is so important. The quote by Kent Beck, "Silence is the sound of risk piling up." Okay. Is that still flashing green, by the way? Hey. You also, ideally, pair it with continuous delivery. Again, continuous delivery is one of those things that suffers from definition slip, or whatever we want to call that. People will have a CI server set up, and there'll be an automatic build, and you ask them what their branching strategy is like, and they say, yeah, we have continuous delivery. And you're like, which branches? Oh, yeah, I've got this feature branch that's been alive for 2 weeks. And when was the last time it was merged into master? Merged? What? That's not continuous delivery. By definition, literally by definition, the people who invented the term, if it's not getting merged into master every day, it's not continuous. Simple as that. That doesn't mean you have to merge your code into master every day. But don't call it continuous delivery because that's not what it is. That's fine. Do what works for you. But words have meanings. There's a reason people suggest these things as good ideas. It's worth going and learning out what context those good ideas actually work in. If that is not your context, great. You owe yourself the favour of trying to work out why it doesn't work for you, whether it's genuinely not working for you for real reasons or for reasons you could fix. Right? Because these are good ideas. They're not the only good ideas. And this is why continuous delivery is important. Again, from Kent Beck. Any gap between what is on a programmer's desk and what is in production is a risk. And the gap's even bigger if it's only in their head. So, yeah, right. So close that gap down. And people say, oh, well, if we have for me, continuous delivery is even better with continuous deployment, by the way, which is, that's a state for me where if I commit something to master, however it gets into master, I just assume that about a few minutes later, it's going to be running in production. And I work backwards from that point. Whatever I need to do to make that a possibility, that's what I do. Now, if that means I actually do need like a dev branch, there's a gap because the org can't quite, you know, their test suite isn't good enough and they haven't quite got the skills yet, great. So you do that, right? But master means it's in prod 5 minutes later or something is a great place to start with, well, how could we achieve that? Because again, it gives you a target to work towards. If you do that, you reduce risk, not increase it. Because again, people will think, well, if we just make these changes and they go into prod straight away, we're going to break stuff. It's like, and then you look at their incident history with their 6-month releases and you're like, you seem to be breaking stuff a whole lot right now. And they're like, well, and you say, okay, well, what if I could break stuff and then fix it 5 minutes later because I have continuous delivery into prod, then I could fix the issue. And they're like, so it reduces risk, not increases it, right? It's a very important thing to again, these tools all support things like that you think of people maybe as these blockers, you know, audit and security and those kinds of things. They're in the way, they want to stop us delivering. No, they have valid concerns. You need to be auditable if you have a legal constraint that says you need to be auditable. You can't magic that away with wishful thinking, right? Likewise, if you have security concerns, and face it, everyone does, you can't magic those away by just sitting under your desk, right? Things like continuous delivery actually help you with those. Nothing is much more auditable than the only way I can get code into production is if it went through a CI server with logging. And you can't get around that. That's auditable. Me just monkeying code in prod as a quick fix, that's not as auditable, right? So CI is my friend, not my, and the auditors aren't my enemy, right? Stops me from making mistakes as well. It's, again, if you go to Toyota, it's the poka-yoke of an and-on chord of programming. And mainline development is the other thing. How am I going for time? Yeah, a couple of minutes. So I just mentioned, again, branching strategy. So this is the Git flow strategy taken directly from the Atlassian, because we all know the Atlassian are the Agile experts on the planet, the Atlassian website. And you can see it's very straightforward with master is over here, there's hot fixes going into master, and then there's releases going into master here, there's a develop branch down here, and then feature branches that end up in development. Very straightforward, right? Then you've got mainline development. There's master, and that's it. That's mainline development. Tell me which you think is simpler, right? The problem with this is it makes team members in teams have to talk to each other now. And that really pisses them off. Okay? That, you could probably get away with not speaking to people for a month. And that's really comfortable. Okay? That's why this is actually more important as a target. Because it forces those problems to come out. And they come out early as well. Okay? Again, Toyota philosophy, if I want to have a problem, I want to have it as early as possible so I can work on it. I don't want to send those problems down the line. And finally, I'll jump into the example at the end of this. I said I was going to do TDD. We'll do what we can. CRC cards, something else from TDD, pardon me, from XP. I found really useful. They originally came from, if you were in object-oriented software, you would write out the class you were writing, and anyone who's done the toy robot test that John Eves came up with will recognise this. You write out the responsibilities of the class and the collaborators. So if I'm writing the toy robot, and if you're not familiar, that's okay. But this thing might be responsible for performing movements safely, and it might collaborate with the table, some commands, and a direction thing to help it figure out what safely really means, for example, right? At my edge of the table, that kind of thing. The point is you literally write this on those little index cards that people used to put on their walls a while ago when we had walls instead of Jira. And if you can't fit the stuff in the card, that's telling you that you have too many either responsibilities or collaborators. I forgot to mention the single responsibility principle out of Solid, right? That's what all that loose coupling and tight cohesion is sort of getting at, is the single responsibility principle basically says something should be responsible for one thing, ideally. Whatever that one thing is. It could be varying scope. But that's where microservices come in, right? And I could, instead of class, this could be microservice. And it could be responsible for a certain thing. And it could collaborate with other services or an event bus or something like that, right? Or it could be even inside a class, a particular function or method or whatever. Or even an if block. These things are all, it goes to any level, right? So these are actually really useful to map out what's going on in your system. And if you see 100 collaborators and you can't fit all the responsibilities on a card, that's telling you it's doing too much. Simple. So I'll come to that last slide in a minute. So really quick example of TDD. If I want to do some code for a little arithmetic thing, I got this from Code Wars. Basically, I'm going to be passing in two numbers and what kind of operation I want to do. Literally, add, subtract, multiply, divide. So if I pass in the numbers 1 and 2 and add, I should get 3. That's the numbers added up, right? If I come to here, the only test I've got at the moment, which I will run to prove that it fails, expected 3, received undefined. Perfect, right? What's the first thing I write in here? Remembering that I've got to have different conditions for if that's multiply, divide, subtract. That's where we're going with all this. So I need to be able to account for all that at some point. What do I write in here? Exactly. I run this test. And people don't understand, well, how do I account for all of that other choices we have to make? You need to go back and have a look at TDD, because that return 3 is the crux of it. I don't write any more code until I have another test to tell me I need more code. And then I make sure my test is actually testing my code. That's TDD in a nutshell. So the people who said return 3 understand TDD. All right? That's it. There isn't much time for questions because people are rolling in, and I want to let my next presenter set up. And also I'm sick as all hell, so I'm going to go home. But thank you very much for attending. This is me, as I said. That's my Twitter. And I hope that was useful. Thank you.